All right. Well, hello everyone, and welcome back from last week. Uh, you've probably noticed that there was a video that we put out this week. We did the cauliflower's tale. Finally, we'd had the script written for a couple months, I think, but I finally had some time to work on that. So we did it. Yay, team! So joining me today is my host and co-host Peter, as always.
I haven't watched it yet, but I'm really excited. I didn't know cauliflowers had tails. So,
It's quite a long video. It's like 50 minutes, so
oh,
that's pretty long for us. Yeah, and then we also have one of my editors. We have Nestlig.
Hello. Good to
Welcome.
be back again.
Yes,
Wow.
yes, we missed you
yes.
last week. Um,
Yeah.
Nestlig has been doing the photosynthesis show, right? So every few weeks or so, Nestlig does an episode of
Yeah.
his photosynthesis show.
I've been backed lately and I haven't I made a few slides, but there are many more slides I need to prepare. So it can take a while. It may not even happen this year
Oh, that's okay.
for the next episode, yeah.
Um, I understand it takes time. But this week, actually, I talked about photosynthesis to my students. So we talked about the process of photosynthesis, the evolution of oxygenic photosynthesis. Then we use that as a jumping off point for discussion of the carbon cycle and then climate change. So we talked about how global warming and ocean acidification are caused and all that fun stuff. So that finished with those lectures today. So yay, climate change. Hello all. Hello Aprinder and Brian Stevens and Nan and Eric Davis. Hello everybody. Good to see you. So one of the things I talk about in that lecture on climate change is we discuss responses to some climate change arguments. So for instance, like isn't climate change caused by volcanoes or is it the sun? We respond to those arguments. We respond to like, well, how do we know that the carbon dioxide that's in the atmosphere is increasing? And how do we know that even if it is increasing, how do we know it's coming from the burning of fossil fuels? We discuss all of that. We go through that whole process, all that fun stuff. So we cover a lot of stuff. Which is real nice. And Jake Nelson, hello, welcome. So, all those. So we kind of cover a lot of talking points. We do talk about the history of kind of climate change denial. It's fun. And then in the other class, we talked about thermo and osmo regulation. So anatomy. We're doing a lot of anatomy stuff in the other class. So, but anyway, so we're gonna do some more. I guess before we get there, there's been a lot of news recently in the U.S. relating to something that does photosynthesis, and that is soybeans. Are you guys up on the soybean news?
No, I haven't.
Yeah.
I haven't heard
Well,
it.
Peter, you see, and everybody who's watching, the man who we have as our president of the United States is dumb. He's quite dumb.
Yes.
And he's made a big deal about tariffs this time around. Well, in this administration, a lot of people have talked about his tariffs. He wanted to put like a flat tariff on most countries, but then for a few other ones, like China, for instance, he wanted really high tariffs so that we wouldn't import things from China, right? Like technology and
Isn't that
clothing and stuff like
counterproductive?
that.
Isn't that counterproductive since all of his
Well,
merch is made in China?
yeah, a lot of his stuff is made in China. A lot of things in the U.S. are made in China. Parts for
Well,
factories and like
especially the
toys and
MAGA
technology.
merch, especially the MAGA merch, which flags, caps.
That's probably true. I mean, a lot of cloth products do come out of like Vietnam, Laos, and Cambodia, also, and in Thailand and all that area. But yeah, you're right. A lot of those products probably do come from China. But but we talk a lot about tariffs right now. But what I think people may or may not remember is Trump did a lot of stuff with tariffs in his first term. He tariffed China in his first term, and he tariffed, and in tariffing China, this affected our farmers, like in pork and rice and also soybeans. And this caused the collapse of a number of agricultural companies, and Trump had to bail them out for $2 billion in his first term. And so we're back at it again. We have come full circle. We are tariffing China again, and this is adversely affecting our farmers again. And let it be known, farmers voted, over 90% of them voted for Trump.
Yep.
So over 90% of them voted for their farms to collapse because we're not giving our Jackson Understatement of the Year awarding coming from Brian Stevens. Because he's done it again. He did exactly what he said he would do. He said he would tariff China. He did it. He made good on that promise. It just so happens that hurts us, and everyone said that would hurt our economy. Here we are, so that was very dumb. So soybeans right now, our soybean farmers in the U.S. are hurting quite a lot, and China's still getting soybeans. They're just getting them from Argentina now instead of from here. So.
And Argentina was also bailed out by Trump. So yeah.
Yes, Argentina was bailed out to the tune of, I think it was $25 billion by the Trump administration. And they also have a terrible economy. Milei, right, is the president of Argentina, right? Isn't it Milei?
Yeah.
Argentina. And he's also, if I remember, yes, Javier Milei. He's also a crazy, like, libertarian guy. He was the one who Musk went on stage with and like had the chainsaw and everything, and they were going to cut regulations and all this. Oh, and the government collapsed. Oh well, or the economy collapsed. Oh, well,
Jackson, you say Trump is dumb, but you know what borders on stupidity?
What?
Mexico and Canada.
That's very true, unfortunately.
I mean, yeah, it's sad to see things being run into the ground, but it's also oddly satisfying seeing people who voted for Trump now having their businesses disappear because of the tariffs that Trump's put in place, and the people that won't work anymore because they're afraid of ICE raids.
Yep.
Yeah.
Which, it's worth pointing out, the cruelty is the point. The goal is to be cruel. That's always the goal.
I think it's also the case that a lot of these farmers just fully expect to be bailed out eventually.
That's also probably true, yeah. Is, oh well, if he tanks our company, at least he'll give us billions of dollars. Yeah, okay, that's great. I love that that's happening.
Yeah, if there are no consequences, then why not? Yeah,
that's true. Yeah, absolutely. Well, yeah, no consequences for them. For other sectors of the economy, other people, yeah, forget about them. Who cares? But yeah, you're right. So anyway, all right. Are we ready to jump into some PragerU?
Yes.
Before that, I also wanted to mention that I have been, like 2 days ago, I was on Rebecca for what's a channel again called? You're
talking about Bread of Life?
Yeah.
The creationist whom we had on, we talked with Dapper.
Who didn't allow you to talk about more than one topic and then ended up changing the topic every single time.
Yes. So you went on her show?
Yeah, but I think I went on her other channel called Examining Origins or something like that. I mean, I went on there for half an hour. She like at the start of the live stream, she brought up a paper about the origins of the ribosome. And she was like, "Oh, this whole paper is just storytelling. They cite no evidence." But I went on to say like, "Oh, actually, they do cite evidence." But yeah, it went nowhere, unfortunately.
She is incapable of like listening to reason and having these things stick in her head. And I think she's just dishonest at this point. I don't
Yes.
think
Yes.
she believes what she's saying.
Well,
Dan, Zach. what'd you say?
Dan made a
Yeah.
video. Dan was so triggered about this that he made a video, and he calls on every single atheist that if they see a title, come bring the evidence, go on there and then say, okay, I concede evolution is fake. Now let's talk about the evidence for creationism, because there's none of them that can present any evidence for creationism.
Yeah.
So
Yeah, eventually she tacitly admitted that she did not understand the paper, but then she still went on to say like, oh, I can tell when I can pierce out the evolutionary nonsense, as she put it. And then I was like, wait, if you don't understand the paper, then how can you piece out the nonsense if you don't comprehend what is even being said? And then that didn't.
If it doesn't make her feel good, if it hits her right in the feels, then it's fake. That's the vibe check. Doesn't pass the vibe check.
And in all fairness, ever since she fell out with Sal Cordova, she doesn't have anyone to run the paper by to tell her what it does or doesn't say anymore. Because Sal Cordova was her go-to guy.
Mm-hmm. Right, because he did like I think physics and chemistry is his background, I believe. So yeah, but Zach Hancock went on there. Jonathan Baker, who does the like geochronology stuff. He went on and talked to her, and she just like I think she's just dishonest. I don't think like it's very clear she doesn't have good arguments, and then when her arguments are like the holes poked in her arguments, she's kind of like a flat earther in that she just kind of concedes at that time, and then the next time you see her, she's back to the same arguments. Like nothing ever happened. And that's just dishonest. And I don't have time for that sort of stuff. So that's why these people tend to come on only once. They only want to talk to us once. We poke a bunch of holes in their argument, and they never want to come on and talk to us again. Which I guess I can't blame them.
And the titles of her videos, I mean, come bring the evidence for evolution if you have the courage, or if you're not scared. I mean, why should anyone be scared?
Yeah. I mean, the worst that can ever happen is you're wrong, right? And then if you're wrong, you can become correct, which means you're not wrong anymore. There's only upsides, you know? So
if you go on a channel like that, all you're going to hear is nuh-uh. And that's basically it.
Yeah, I mean, that's kind of what she did with, because when we had our conversation with her, when Dapper and I had our conversation with her, we went through this whole paper on the evolution, so these researchers evolved Saccharomyces cerevisiae to be multicellular and then to be macroscopic and multicellular. And she would ask like the question she asked were fair during it. She would say like, well, how do you know that this is true? Or how do you know that they did this? And then we could show like, okay, well, they say it right here. They said that they did it right there. Okay. Well, then, she asked another question like, oh, well, how do you know about this? Well, they say it right here. It's in their supplementary materials. It's right there, and it was fine. But then at the end of it, she said, she was just kind of like, well, how do you know that happens in evolution? And then Dapper was like, well, because for these reasons, right? This is the backbone of evolution. And she's going on, I'm sure, and just kind of ignores everything we talked about. So whatever. Anyway, there was a paper that Brian Stevens provided us with last time that claimed to show that there was no statistical correlation there was no statistical causation, right? But of carbon dioxide emissions on temperature. This paper claimed that while it may look like correlation, there was not causation.
Oh, do you mean over like a eons scale, or? On what scale are they talking about?
Let's see. Well, it had a short-term and a long-term scale. Let me see if I can re-find that paper.
Like
Um,
if you're looking at the total history of the Earth, then yes, there is no correlation because one other aspect is that this is something we discussed during like one of the episodes of photosynthesis is that the sun used to be much fainter in the
Right.
past. So if you don't account for that and also other factors, you won't see a very tight correlation between CO2 and temperature. But when you do account for those factors, then yes, CO2 is a very it's a thermostat that controls the climate of the Earth. But of course, you have to account for additional effects as well. And of course, then the argument from the climate skeptics will be like, but then how do you know those factors aren't true right now with climate change? Well, we can monitor the sun, and the sun is not changing significantly. Like we also discussed this in our video from like 5 years ago, where the sun is has actually on average decreased in brightness in the last 20 years or so.
Here it is.
It depends on the time scale. Yeah.
So this paper was titled "The Relationship Between Temperature and Carbon Dioxide Emissions: Evidence from a Short and Very Long Dataset" by David G. McMillan, who is at the Accounting and Finance Division at the Sterling Management School, and Mark E. Wohar from the Department of Economics. So, two economists wrote a paper titled "The Relationship Between Temperature and Carbon Dioxide Emissions: Evidence from a Short and Very Long Dataset." And what their paper says is, quote, "The debate regarding rising temperatures and carbon dioxide emissions has attracted the attention of economists employing recent econometric techniques. This article extends the previous literature using a dataset that covers 800,000 years, as well as a short dataset, and examines the interaction between temperature and carbon dioxide emissions. Using root tests reveal a difference between the two datasets. For the long dataset, all tests support the view that both temperature and carbon dioxide are stationary around a constant. For the short dataset, temperature exhibits trend stationary behavior, while carbon dioxide contains a unit root. This result is robust to nonlinear or trend breaks. Modeling the long dataset reveals that while contemporaneous, carbon dioxide appears positive and significant in the temperature equation, including lag results in a joint effect that is near zero. This result is confirmed using a different lag structure and vector autoregressive model. A generalized method of moments approach to account for endogeneity suggests an insignificant relationship. In sum, the key evidence from our analysis is that carbon dioxide has, at best, a weak relationship with temperature, while there is no evidence of trending when using a sufficiently long dataset. Thus, as a secondary result, we highlight the danger of using a small sample in this context. So this paper is saying that there is at best a weak relationship between carbon dioxide and temperature.
Can you link the paper in the chat or in the?
Yeah, absolutely. Okay, there you go. There it is in the chat. So, of course, I'm going to have to pop open this paper with some methods that don't exist. And so this paper's in the Applied Economics journal and has, I think it said, has been cited 19 times. It has been cited 19 times. So I think this is quite interesting. So that paper was cited by some other. It was cited by some other papers, and so McMillan and Wohar. Here's another paper that cites it. This paper in the journal Energy from 2023 says, "Impacts of alternative energy production innovation on reducing carbon dioxide emissions, evidence from China. It says, although environmental economics research explores the impacts of green innovation on reducing carbon dioxide emissions, most studies ignore these effects in emerging economies. This paper examines how alternative energy production innovation reduces carbon dioxide emissions. Using a sample of 30 provinces in China during the 1997 to 2017 period, we find that AEPI is negatively correlated with carbon dioxide emissions. Specifically, the results show that innovations in raw coal and crude oil are negatively related to carbon dioxide emissions, while innovations in natural gas are positively related to carbon dioxide emissions. This study contributes to research on technological innovation and environmental econometrics. First, we find AEPI is the main driver of all types of green innovation in reducing carbon dioxide emissions. Second, we explore the heterogeneous effects of different energy sources and deepen our understanding of different reduction mechanisms. Okay, so that's one paper. So that's a paper that talks about green energy innovation. So if you look at the paper that I put in there, figure 1 shows temperature and carbon dioxide for the last 800,000 years. And what seems interesting to me is the paper says, as we just read in the abstract, that where is it? That both temperature and carbon dioxide are stationary around a constant, by which I'm taking to mean they like fluctuate in a orderly sort of pattern, right? They fluctuate. They do fluctuate, and there is a through line that they go around, right? So there's a regular pattern of going up and then going down, then going back up and going back down. And the same is true. So, like, if you look at that, I know, Peter, I apologize for not having these to you in advance. I don't know, Nestle, that looks to me like they're correlated. It'd be very shocking to me if these are not correlated.
Yeah, I'm not sure how they did the analysis.
So, and the same is true if you look at temperature and carbon dioxide since 1850. It starts low and it goes upward, and the temperature also goes upward. It is very odd. So, I don't know. It is very odd, this paper.
Yeah, I brought it up, but for some reason I can't see the figures.
Oh, Peter, you have to use not Sci-Hub to bring it up.
Ah, okay.
I suspect that they don't account for like other fluctuations, like the El Nino and La Nina cycle, for example. If you ignore those things, then you will introduce a lot of noise in the data, which
It's
you don't
possible.
account for, and then you will reduce the signal that it gives.
So
CO2
one thing, so this paper claims, so ultimately this paper claims that there is no relationship, right, between these two variables, right? So one of the papers that cites this paper is titled "Global Carbon Dioxide Emissions and Global Temperatures, Are They Related?" And that is by Luis Gil Alana and Manuel Monge from 2020. So this paper is from 2013. So they cite this paper, Macmillan. So let me find. Now, what's interesting is they cite this paper. Whoops, I can't find my mouse. There it is. So they cite the paper as saying the most noticeable aspect is the strong correspondence between temperature and the concentration of carbon dioxide in the atmosphere. Right? So they cite that, and then they cite Macmillan and Wohar, 2013. Then a little bit later in the paper, they cite them again saying Among the few papers relating temperature and emissions, McMillan and Wohar, 2013, investigated jointly and individually the two variables using unit root tests and other autoregression models, concluding that carbon dioxide has a weak relationship with temperature, not finding evidence of a trending pattern. And then a little bit later, they say, so then in this paper, they say, in this paper, we have related global carbon dioxide emissions with the global temperature by using a long memory model. We use this approach based on the overwhelming evidence supporting the existence of this feature in the data. We start by conducting the univariate analysis of each series, which are global carbon dioxide emissions, and 4 temperature series corresponding to land and ocean, northern and southern temperature anomalies. The univariate results indicate that the carbon dioxide emissions are not mean, reverting, with the estimated value of D, the differencing parameter, being equal to or higher than 1 in all cases. This implies that the series is highly persistent, with shocks having permanent effects on the series. For the temperatures, the estimates of the differencing parameters are much smaller, ranging in the interval 0, 1, and thus supporting long memory and mean reversion behavior. Thus, shocks here will be transitory, though with long-lasting effects. As a consequence of this different pattern in the behavior of the two variables, we impose the assumption that the emissions are weakly exogenous, and including this feature in a long memory regression model, the results indicate that the emissions produce a significant positive effect in the temperatures, which is consistent with the works of McMillan and Wohar, 2013, and a few others, and at the same time displaying a significant degree of persistent with shocks having long-lasting effects. Thus, a shock in the emissions affecting the temperature will be permanent, though transitory and disappearing in the very long run. So this work could be extended in several directions. Thus, for example, carbon dioxide concentration could have been taken into account instead of carbon dioxide emissions when looking at a long-run relationship between pollution and temperature. Also, the analysis could be conducted. It talks about future work. So, in this paper, this paper looks at the data and shows that there is a correlation between these, right? It's not that there just is kind of seeming one. There is actually a relationship. The results using this approach show a significantly positive relationship between the two variables with a long memory pattern. So that's global carbon dioxide emissions and global temperatures. Are they related? So using that paper, the other paper I shared at the end is much more reflective of the actuality. Trojan sources, it is a Trojan source. What was the other paper, Brian? Could you post that one again, please? I would appreciate it. So at any rate, it does show that they are related. So, okay. And I'm sure there are lots of other papers in here too, but we're going to move on to the video. All right, ready? Nestle, is there anything you want to say about the paper, or?
I was reading the first paper a bit, and I think they are, so far as I can tell, I think they are cherry picking. Like in section 2 and in the second paragraph, they I will read the paragraph.
Okay.
Figure 1 presents the long data period, and figure 2 presents the shorter data period. Well, tables 1 and 2 present some summary statistics. And then they continue, of particular interest in the statistics presented in these tables is that, well, CO2 is it as its highest level during the sample in the last observation. The same is not true for the temperature. Basically, they say that, the point where temperature is the highest is not the same point where CO2 is the highest. And I'm like,
why would we expect it to be?
Yeah, they are simply cherry picking. They are like, this is not how you establish a trend or a correlation. You're not looking at the highest point of each data set.
Right. So
the whole, it's
right. Like, so if
that's
temperature
already alarming.
is So like if carbon dioxide precedes the temperature, right?
Mhm.
So you have
Yeah.
increase in carbon dioxide before you have this rise in temperature, you're going to have like lower carbon dioxide, right? It's not going to be directly correlated because there's going to be that like lag effect, right? And so they're
Exactly.
basically saying like screw it is what you're saying?
Yeah, and in this also so funny that you mentioned it because they are doing the reverse regarding the Milankovitch cycles. Like they note that. Hold on, just to see. Um, Also, here they continue. Indeed, for the long data set, the highest recorded temperature preceded the lowest recorded temperature. Yeah, because the Milankovitch cycles determine the temperature, and the CO2 in that case CO2 follows temperature, as opposed to the other way around. So
Hmm.
yeah, it's not surprising, but that they think that they assume that CO2 and temperature have to be correlated in lockstep with each other.
Right.
There's no lag allowed, and there is no other factors allowed, like
Right.
El Nino and La Nina cycles, for example. So that is, yeah, it's really bad.
Yeah.
But in any case, we can we can continue on with Prager FU.
Eric Davis points out it seems odd that economists are doing climate science analysis and publishing them in an economics journal. Yeah, you're right. It doesn't make them automatically wrong, but it is very shocking. It's like, yeah, as soon as you look at that, you're like, whoa, hold on a second. Why are you doing that? Shouldn't you be publishing your data in a climate journal? It's kind of like when Mark Armitage was posting his so-called like living dinosaur tissue in a microscopy journal, who was checking his microscopy work, but not his paleontological work. So this is kind of the same thing. So the economists who maybe peer review that journal are looking at the math, right? So they're checking their math and they're saying, oh, well, the math you did is right, but they're not accounting for the climatological effects. Something like that would be my guess. Brian put in the chat the phase relation between atmospheric carbon dioxide and global temperature that says using data series on atmospheric carbon dioxide and global temperature, we investigate the phase relation, lead/lag, between these for the period January 1980 to December 2011. Ice cores show atmospheric carbon dioxide variations to lag behind atmospheric temperature changes on a century to millennium scale. But modern temperature is expected to lag changes in atmospheric CO2 as the atmospheric temperature increases since about 1975, generally is assumed to be caused by the modern increase in CO2. In our analysis, we use 8 well-known data sets, and it gives all of them. The maximum positive correlation between carbon dioxide and temperature is found for carbon dioxide lagging 11 to 12 months in relation to global sea surface temperature, 9.5 to 10 months to global surface air temperature, and about 9 months to global lower troposphere temperature. The correlation between changes in ocean temperatures and atmospheric CO2 is high and do not explain all observed changes. Right. So, okay. So there's that paper that goes into it much better than the one we're looking at. All right. Let's do PragerU. Let's get him. Thank you, Brian, also. I appreciate it.
Temperatures and carbon dioxide levels do not show a strong correlation.
Uh-oh.
In fact, over very long time spans, periods of hundreds of millions of years, they are often completely...
Again?
Okay, so you see Nestle, so he said hundreds of millions of years. So he's being very disingenuous.
Yeah, this is exactly what I was bringing up in the beginning. If you're looking at this scale, the fact that the sun is like increasing in brightness over millions of years, that becomes important. But of course, if he's not accounting for that, and then you end up with this figure like this.
Yeah, he's using like a fake graph. Also, like this isn't corresponding to anything. There's no time. There's nothing on here. There's no parts per million.
I know what it's to say, like you see this graph sometimes. Yeah, it is regarding the eons of the Phanerozoic.
Really? Okay, so he's just he's just covering.
But there is no
the whole
it just doesn't give the time scale. Yeah, that's the only thing.
Okay, cool.
Mhm.
I love PragerU graphs. There's a very funny bit by Sean when he does how PragerU lies to you, and he talks about like what's the scale here? Time, distance, temperature. So
Yeah, there's
okay,
also there's also I remember like one scale has just dollar signs, and that's it.
right,
Dollar signs. Yeah.
correct. Yeah. All right, we can keep going.
Out of sync with one another. Over and over again, within virtually any time
Again.
frame, we find the climate changing for
Oh, I found it.
reasons we do not fully understand.
Here, Peter, can you pause for a second? I'm sorry, I found the graph he's using. Thank you for pointing that out, Ness. Like I never would have figured out that that's.
Yeah, I see this graph like what's this the Lord from the UK who Moncton or what's
I don't
his
know.
name?
So,
Potholer has made videos about him.
so
Like
this
this yeah.
is
And
from.
he brings he brings us up the same figure again and again. Yeah.
So yeah, so atmospheric, yeah, CO2 parts per million with millions of years ago, and you can see that there's not really a correlation from Burner and Cathavala 2001, whatever paper. A revive. Wait, is that it? Burner, is this it? Yeah, I think this is it. It's called Geocarb 3, a revised model of atmospheric carbon dioxide. Uh, yeah, a revised model of atmospheric carbon dioxide over Phanerozoic time is the paper. So okay.
I found the image. Yeah.
Well, thank you for pointing that out. I appreciate it.
Mm-hmm.
But yeah, this is silly.
Well, you can see that like as you go into the past, ignoring the dips and up and peaks,
Mm-hmm.
it's the CO2 was much higher in the past, like in the Cambrian, for example, much higher in the Cambrian, even though the
Right.
temperature was not much higher than today. But the reason is that in the very distant past, the sun was much fainter than today, so CO2 had to like compensate for the faint young sun in the distant past. And
Mm-hmm.
that's why you see this mismatch between temperature and CO2. But when you do account for this the faint young sun, then there is a very good correlation between CO2 and temperature. So of course they will never bring this up. It's very ironic. When it comes to climate change today, they will bring up the sun, but when they go into the distant past, they don't bring up the sun.
Yeah. Wait, they're being dishonest? What are you talking about, Nestle? That's crazy. I can't believe you would suggest something like that. I keep seeing Scotty's. I was trying to find the other paper, Scotty's 2002. Oh, okay. So I think is it this one? 2002 climate change. It's kind of hard to figure out what exactly. It doesn't matter. Okay, all right, let's keep going.
But we do know there are many more factors in play than simply the concentration of CO2 in the atmosphere.
That's true.
Factors such as the shape and size of the Earth's elliptical orbit around the sun, activity from the sun,
True.
and the amount of wobble or tilt in the Earth's axis, among many others. Even the relatively short 300-year period from the peak of the Little Ice Age to the present has not been steady. The latest trend has been a warming one, but it began nearly a century before there were significant carbon dioxide emissions from burning fossil fuels. And there has been no significant warming trend in the 21st century. Contrary to media headlines, the trend over the past couple of decades has been essentially flat. Meanwhile, human-caused CO2 emissions are higher than ever.
Nestle, what is he talking about?
Yeah, it's like we have to also account that this is also an old video. So, but in any case, what they were doing back then is they said like, oh, they go back like a couple of decades, and they put a pin on the trend line, and they say, this temperature is about the same as today, but then they ignore the whole trend from many decades. That's how they do it. It's again, it's looking at 2 data points and just ignoring the whole trend.
Right.
And
I
that's how
am
they do it.
aware that that it is possible to do that kind of stuff. Like, so, like for instance, if you want to, one thing I think it was Steven Crowder did, and this was in I think it was an H Bomber Guy video. Steven Crowder put up a chart that showed the Greenland ice sheet is increasing in size. Now it turns out that was over like a it was over like a few year period, like 5 or so years. But then H Bomber Guy like looked at that graph and was like, "Oh yeah, it is increasing." And then he like widens the scope and shows that it's been like downhill. Like there are minor reversals here and there. You have little growth phases, but the overall size has just dropped like consistently for decades. And so it was very
I put an example, a figure in the live chat as an example what they are doing right here.
yes, right, exactly.
Yeah, that's what they mean when they say, "Oh, in the last few decades, the trend the trend has been flat." But of course, they
And
ignore the
you could
whole line.
even, and like Nestle, you could even like if you wanted to, you could show in instances where the temperature has gone down over time, where the average temperature has
Right.
gone down.
Again, this is all like the main effect that determines these ups and downs in decades is the El Nino La Nina cycle. Basically, like I forgot which one. Let's see here. Does El Nino increase temperature or La Nina increase temperature? I forgot which is which. But in any case, when one happens, the ocean absorbs a net amount of energy from the atmosphere. So then the temperature will go down on the surface. But then when it switches back to the other phase, then the ocean release a net amount of energy into the atmosphere, and thereby increasing the surface temperature. And that's why you see these ups and downs in decade scale. But of course, when you look at the whole phase of like the last 200 years, then yeah, we do see a very noticeable increase in temperature compared to the pre-industrial age.
Right. Yeah. This is just it's just dishonest what they're doing. Yeah. Okay. Let's keep going.
About 25% of all the CO2 emissions from human sources have occurred during this period of no net warming. So what are we in for next? Will the temperature resume an upward trend? Will it remain flat for a lengthy period? Or will it begin to drop? No one knows, not even the biggest, fastest computers. All the information I've presented, the increases, decreases, and plateaus in temperature over the ages and into the last centuries, is available to anyone who wants to seek it out. Yet to state these simple facts is to risk being called a climate change denier. Not only is that absurd, it's mean-spirited. It's absurd because no one, not even the most fervent skeptic, denies that the climate is changing. And it's mean-spirited because to call someone a climate change denier is to intentionally link them to people who deny the Holocaust. So maybe it's time to stop the name-calling. Predicting the climate, one of the most complex systems on Earth, with thousands of inputs, many of which we don't understand, isn't an exact science or anything close to it. Maybe it's just a tad arrogant to suggest that we can predict the weather or the climate or just about anything 60 years from now. The science is not settled. The debate is not over. The climate is always changing.
Sorry.
It always has, and it always will.
So
I find it very funny that in one instance he's like, "You're hurting my feelings," and then he follows that up by, "But you're arrogant."
Well, yeah, of course. I mean, they have to do unto others what is, what they claim is done to them. Also, I don't think it's, first of all, that was a crazy thing to say, that calling someone a climate change denier is calling them a Holocaust denier, like, or is linking them with Holocaust deniers. That's an insane claim to make. I would never, and I don't think anyone assumes that if you're a climate change denier, then you deny the Holocaust. I've never heard that.
I think he doesn't like the word denier.
Well, that may be the case, but
that's the only thing, and yeah. But
I mean, if you're a vaccine
it's
denier,
not just that PragerU is denying; they are being paid to lie.
Right.
That's it. Yeah.
Yeah, I mean, he's being willfully disingenuous about the data he cites, very selective with the data he cites. This is all just disingenuous. And then to turn around and say, like, oh, it's so mean to call me a climate change denier. You are denying anthropogenic climate change. That is what you are doing. Your goal is to be paid by PragerU to say that climate change isn't happening. Like, like, what are we talking about? Nobody thinks it's going to get cooler, like significantly cooler. Like the trend is just going to reverse in the next couple of years. Nobody thinks that. They don't think that. They know this is all a lie. They've known this for decades. There are, books that go through how they know it's a lie, like Merchants of Doubt. So, yeah, just silliness. If people like don't want to be called things like deniers, then maybe they could acknowledge the consensus of experts in the field. Like, I won't call you pro-plague if you acknowledge that vaccines work, if you acknowledge that they're effective. That's what happens. So, okay. All right. Let's finish out with this one.
I'm Patrick Moore, co-founder of Greenpeace for Prager University. What are two of the dirtiest words in the English language? Well, if you're concerned with global warming...
Demonetization, here we come.
PragerU? Oh, sorry.
That's one of them.
I was guessing Patrick Moore.
Right.
That's just mean.
It's really funny to me that this guy, it's mean-spirited. It's really funny to me that this guy is a climate change denier, considering he's one of the co-founders of Greenpeace. But I guess he's kind of like one of the, I can't remember what the guy's name was. One of the founders of Wikipedia is like a crazy conservative dude now. And he hates what Wikipedia is. He was complaining about it on Twitter the other day. He was like, there are too many academics on Twitter. Or no, I'm not on Twitter. On Wikipedia. So there are too many academics on Wikipedia. There's too much scientific consensus on Wikipedia. They don't let you post like conspiracies and stuff like that. And it's like, my guy, what's wrong with you? What happened? Why are you like this? So sad.
Warming, as so many people are these days, the answer is obvious. The two words are carbon dioxide,
dun, dun.
Or as it is known by its chemical symbol, CO2. One atom of carbon and two atoms of oxygen. If we pump much more of it into the atmosphere, the argument goes, we're going to alter the climate, catastrophically.
We are.
According to the Intergovernmental Panel on Climate Change, the IPCC, CO2 emissions from fossil fuels, which constitute 85% of our energy use, must be reduced to zero by 2100. If we don't save ourselves from ourselves, we're toast. That's the claim.
Yep.
Here's what's strange, though. All life is carbon-based, and the carbon for all that life originates from carbon dioxide in the atmosphere. All of the carbon in the fossil fuels we are burning for energy today was once in the atmosphere as carbon dioxide before it was consumed by plankton in the sea and plants on the land.
Not that kind
Coal,
of plankton, but
oil, and natural gas are the remains of those plankton and plants that have been transformed by heat and pressure deep in the Earth's crust. In other words, fossil fuels are 100% organic and were produced with solar energy. Sounds positively green.
This is so
If
disingenuous.
there were no...
Okay, this is so immensely disingenuous. Obviously, I think we said this before, but like, The claim has never been that we need to scrub either carbon from life, which would be impossible, of course, or carbon dioxide from the atmosphere. Like, that's literally never been the claim. And to go on this whole rant about, don't you know that fossil fuels are the remains of photosynthetic organisms? Yes, that's how we know that the carbon dioxide that's in the atmosphere came from the burning of fossil fuels. That's how we know that.
Why are they called fossils?
Right. We know this. We know that plants preferentially take up carbon-12, and then when we burn fossil fuels, we are preferentially putting carbon-12 into the atmosphere, which is changing the balance of carbon-12 to carbon-13 in the atmosphere. And that's a molecular, it's a fingerprint, you might say, of the fact that we're burning formerly photosynthetic organisms. Like, that's how we know. I'm sure they would argue with that. They'd probably say, like, oh, you can't be sure that the carbon dioxide is coming from, from factories.
Doing a Kent Hovind impression. I see.
As a Dutch guy, I'm really impressed what this guy came up with. So, Nestle, what are the Dutch famous for?
Windmills.
Water management. Did you know that humans are mostly water? So we don't have to worry about floods anymore because it's just water. And we're made out of water. I mean, isn't that a great argument?
Peter, you're so right. I never thought about it that way, but you're right. Everybody is so concerned about floods these days. Don't they know that we need water to live?
Yeah.
Right. What a bunch of idiots.
Yeah.
We're made of water.
I'm gonna start using that.
I mean, anyway.
Right,
continue.
No carbon dioxide in the Earth's atmosphere, the Earth would be a dead planet, period. Talk about catastrophic climate change. Take away CO2 and you'd have it. And yet the U.S. Environmental Protection Agency has deemed this essential ingredient.
A 96% carbon dioxide atmosphere, and I wonder if it's the hottest planet in the solar system, despite being not the closest planet to the sun. I wonder which planet that is. Could it be Venus? A planet with a 96% carbon dioxide atmosphere. It is the hottest planet in the solar system. Why don't they ever bring up Venus in these arguments? I guess it would be catastrophic for their argument.
Well, we all know that Venus doesn't exist. It's just a dot within the dome. Isn't it?
Right. True.
For life, a pollutant. But how can something that makes life possible be bad? Before I deal with that question, let's get clear on our terms.
Did you know
it has become common
because water is necessary for life? Just in case you didn't know, it's impossible to drown. You need water. You have to drink it every single day, so you can't drown. How can it be possible for something that makes life possible to be bad? I'm just asking questions. I'm not being a disingenuous hack.
Yeah, I'm pretty sure this guy's not a fan of waterboarding.
I don't know. He is a conservative. So.
It's entirely safe, because we need water.
How can ammonia be bad? Right? Ammonia is part of biology. Yep, it can't be bad for you. Yeah, it's true. It's true.
To refer to the emissions from burning fossil fuels for energy as carbon emissions. That is entirely misleading. Carbon dioxide is not carbon. Carbon dioxide is a colorless, odorless, tasteless gas.
Wait,
which is an
I'm sorry, what? Wait, well, what? Huh? He just said carbon is part of life. Carbon dioxide is necessary for life. And now he's saying emitting carbon in the form of carbon dioxide is not a carbon emission. How does he say that with a straight face? Like, genuine question. That is the dumbest thing I think I've ever heard from climate change denialists. Nestle, have you ever heard them say that before?
I'm sorry, what? I blanked out for a second. I
Have
was
you-
a bit flabbergasted.
You're just
I
like...
was a bit flabbergasted too.
He said carbon dioxide, emitting carbon dioxide is not carbon emission. Because
Yeah.
carbon dioxide is not carbon.
He's being pedantic. Like it's
Well-
it's not carbon. It's carbon
Well,
dioxide.
he
Like-
did
Well,
spend an awful
technically,
lot of
yes,
time,
but
Nestle, telling us that we need carbon, and carbon is in carbon dioxide. That's the whole rant
Yeah.
that he just finished, and now he's saying
He did.
the exact
It's not actually
opposite
carbon.
within seconds after he finished.
It's like he just forgot what he was talking about. He's like, wait, is my
Yeah.
script? Maybe he has dementia. You know, his first script was like, they're like, Dennis is like, okay, listen, you have to read this whole thing about how carbon is good and we need carbon dioxide. And he's like, okay, all right, I got you. But then he forgot immediately what he was talking about. So they gave him a second script where he talks about how carbon dioxide is not actually carbon.
Yeah. But yeah, he's also like, oh, CO2 is odorless, tasteless, and what was the other thing? Like he said, like
It's
oh,
colorless, odorless,
yeah,
tasteless.
colorless, yeah.
You know what?
But
So is methane. Or,
So
well,
is
no,
water, yeah. So is
well,
water. Like, oh,
No, carbon
they're
monoxide.
bad.
Sorry.
There is no smell. There is no odor. There is no color.
Hey,
So-
carbon monoxide is also colorless and odorless and tasteless, so that's fine too, right? It has to be.
It's like it's the yeah. Like what's also a good example? Like it's just irrelevant facts present framed as if they are somehow relevant towards whether excess CO2 is harmful or not. And of course, the fact that it has no odor, although I am reminded of like a very old video that Thunderfoot did, and he showed that CO2 does have an odor at a very high concentration, too high to even experience. Then you will smell it, but then you are probably already dead. Like if you get too much from that. But what happens is that at a very high concentration, the CO2 will like dissolve into your into moisture in your nose, and it will become very acidic. Yeah,
Okay.
that's what happens. But then again, that is completely irrelevant to whether CO2 is harmful at
Right.
the current levels that we see in the atmosphere. Yeah, all right. Let's continue.
What a dummy.
Indispensable food for all living things. Can you have too much of it? In theory, yes. That's what climate alarmists say is happening now. CO2 levels are getting too high. Are they right? Well, if we look
Yes.
at the big picture, we find something surprising. For most of the history of life on Earth, carbon dioxide has been present in the atmosphere at much higher levels than it is today. During the
we also
Cambrian
didn't
explosion,
have ice caps.
when
All right.
multicellular life first came on the scene,
No,
CO2 levels
that's not
were
what
as
happened.
much as 10 times higher than they are today. From a big picture perspective, we're actually
but the
living
sun was
in
also
a
much
low
fainter
carbon
during the
dioxide
Cambrian as
era.
well,
Here,
so,
Peter, let's pause for a
The
second.
optimal
So we're gonna pause the video here. But couple things, as Nestle pointed out, yeah, first the sun was a lot fainter. Also, we had no polar ice caps for a large part of Earth's history. We do now, and we have cities on the coast, so if the sea levels raise, those get inundated. And also, the Cambrian explosion was not when multicellular life appeared on the scene. Multicellular life had been around since 1.6 billion years ago. That's what Raphatasmia and Ramathalis are. They're red algae. The Cambrian explosion happened about 500 million years ago, so over 1 billion years after we see the first multicellular life. So just every part of that was wrong. Stupid and wrong. Okay, I think we're gonna call it for today. All right, Peter, if you could.
Oh, so only 1 hour today, or
Yeah, I'm just gonna go for an hour.
Ah,
All
okay.
right.
Well, we have to do one more thing. Thank you for watching this video. To keep PragerU debunked, please consider donating through a super chat or a super thanks. Thank you.
I love
Yeah.
that. I love it, Peter. It's
There we go. we have to do that every single time. They do it after every video, so we just went from
That's
one
true.
video to the next. So we should have played it in between, but I mean,
That's okay.
nah.
It was still good. I love it. I love that one. Thank you.
By the
Yeah,
way,
that was.
have you seen the vaccine debate with Professor Dave and Dr. Wilson?
No, I have no interest in watching that.
Mhm.
I
I was at first I was thinking about like reacting to it after we finish up the but I've watched a few minutes and I like I I don't mind Dave, but I do have a problem with this tactic. Like, but in any case, it's really bad. How
What do you mean?
yeah, it's like I agree with the position, of course, but Dave has a
Mhm.
tendency to be very insufferable towards the audience that he's engaging with. So that's the only problem. That's the main problem I have.
Oh well.
So I was again. It's the same issue I find myself having with the like the old debate with David. Nee.
Oh, and James
Oh,
Tour.
yeah, James
Yeah.
Tour. Yeah, exactly.
Oh
Yeah.
yeah, I couldn't.
He
I
again,
didn't get through that one.
he has a
well.
tendency to like engage with the audience in a negative way. But yeah,
Yeah. I couldn't. I couldn't
Mhm.
watch that whole thing. It was too painful. Just a couple of guys yelling at each other, basically. So.
But
Um,
even though despite that, the behavior of the opponents, like they were two old guys, but they were acting like children the whole way. It's really astonishing how bad the whole thing was.
yeah. Okay.
Yeah.
All right. So we're gonna call it for today. But first, if you haven't seen the newest video that we just put out, the cauliflower's tail, you need to go give it a watch because it's real cool. We put a lot of hard work into it. We cover um nearly all non-animal eukaryote diversity in one video. That's why it's like 50 minutes. So yay! All right. So
And,
thank you, Mr. Farina. Yeah.
and don't forget to hit the like button. And if you do have the hype button, hype the video so we can go up a little in the algorithm.
Exactly. All right. Thank you, everybody, for watching, and we will see all of you next Thursday. So, bye, everybody.
Bye, everyone.